GCC Chem 130 students. My name is Dr. Kimberly Smith, and I'm going to be giving you a quick run through from Chapter 11 from the Chem 130 course. So the first thing in Chapter 11 is the idea of collision theory. So this should be common sense, but just to make sure we understand, molecules do have to hit each other, or the fancy word is collide, in order to react and make products. So in the picture, I have a diatomic yellow molecule and a diatomic blue molecule. And then those come together and hit, and what happens is the yellow-yellow bond starts to break, the blue-blue bond starts to break, and the yellow to blue bonds start to form. That's what's in parentheses in the middle. That is called the transition state. That's a very high energy time of the reaction, where we have halfway formed bonds and halfway broken bonds. Now, do you think you can stop the reaction there? No. Either the bonds are going to break or they're not going to break. Either new bonds are going to form or they're not going to form. We either are going to make product or we're going to go back to the reactant. We can't stop in the middle. There's no way to stop with that parentheses creature in the middle there. That doesn't exist in a bottle, for example. So if the reaction has enough energy, we will continue breaking the yellow-yellow, blue-blue bonds and forming the yellow to blue bonds and make our products here. So the products are two yellow to blue molecules. Now, if we don't have enough energy, we'll just go back to the reactants on the other side over there and nothing will have happened. But the point is, molecules have to hit or collide in order to make their products. And the transition state is the highest point in that reaction where bonds are breaking and forming. So there it says old bonds start to break and new bonds start to form. This is considered the transition state, as I said. So a successful collision results in breaking the reactant bonds and forming the product bonds. So we want to get our product to market. So we want to increase the number of successful collisions. We want to make product. For example, maybe you're making a new perfume and you want to make more product. Or maybe you're making a drug for helping people with high cholesterol. So again, you want to make the drug. So in order to increase the number of successful collisions, you need to have a lot of collisions. The more collisions you have, the more likely you are they are successful and they're going to move from reactants to products. As mentioned, you need to have enough energy to get through the transition state. So think of that as an energy hill we have to march over. So you have to have enough energy to get to the products. That's called activation energy, E sub A. That's the minimum energy required to get to the product. So we have to have at least that much energy. And then the molecules have to be oriented correctly. So I'd like you to watch that video separately. On orientation, it shows us that molecules have to be oriented the correct way in order for them to react. For example, if I want to cross my fingers, I need to come in fingers first for them to cross. If I come in with the heel of my hand first, I can't cross my fingers. They need to point towards each other in order to cross my fingers. Okay, so they have to be oriented correctly in order to make product as well. Rates of reaction. So again, to get our product to market, we want to have the reaction go at a reasonable time, hopefully just one day, not 5 weeks, for example. So things we can do to increase the speed or the rate of the reaction is to increase the reactant concentration. If we have more reactants, we're going to have more collisions. More collisions means more reaction. More reaction means more product. We can also increase the temperature. What happens when you increase the temperature to the molecules? Well, they're going to move faster. So if they're moving faster, they're going to hit more often. And they're also going to have more energy. The hits are going to be harder. So we're more likely to get over that energy barrier and to make products. So increasing the temperature is a great way to increase the rate of the reaction. If it's something where we can't increase the temperature because the reactants get unstable, or a different reaction occurs at high temperatures, then you can add what's called a catalyst. A catalyst provides a second path to get to the products with a lower activation energy. So instead of only having one way to get to the products, we're going to have two ways to get to the products. And the catalyst will be the lower energy pathway. And so that one's easier to take. So it's an alternate reaction pathway with a lower activation energy. And again, E sub A is activation energy, and it's the minimum energy needed to get to our products. In this course, we need to mention the idea of equilibrium, and that is that some reactions go backwards and forwards at the same time. So in our equation here, A plus B makes C plus D, but sometimes C plus D can go backwards and make A plus B. So equilibrium is defined as the point a reaction reaches when the speed or rate of the forward reaction equals the rate of the reverse reaction. So we can have those reactions going back and forth at the same speed. That's called equilibrium. If you take Chem 152, you're going to learn a lot more about equilibrium, as that's about a half of the course. So very important concept.